Welcome to the session number 9 from the playlist of oscillations. The topic is the time period of simple harmonic motion, and with regards to this topic, I have selected one question from one of my reference books, and the question here is: a body is executing simple harmonic motion and it has a displacement of 4 centimeter and 5 centimeter from its mean position, when its velocity is 10 centimeter per second and 8 centimeter per second respectively. So its periodic time is, there are 4 options here and we have to find the correct one. Now this session is related to the session number 3, in which we have derived the equation for the velocity of the particle which is executing simple harmonic motion, and the velocity is equal to omega under root a square minus y square, where y is the displacement at any moment of time, a is the amplitude of the simple harmonic motion, and omega is the angular frequency. Now this formula was derived in the session number 3, so every one of you can go through that session. So here the velocity is 10 centimeter per second when the displacement is 4 centimeter. So I will be substituting the velocity, the value of velocity as 10, and a is the amplitude of the simple harmonic motion and y is the displacement. So when the velocity is 10 centimeter per second, the displacement is 4 centimeters. So this y square means y is equal to 4. So this is equal to 16. And when the this velocity is 8 centimeter per second, then I will be getting another equation as 8 is equal to omega a square minus 25, because y is equal to 5 in the second case. So if I square both these, let us say this is equation number 1 and this is the equation number 2. Now on squaring the equation number 1, I am getting the value as 100 is equal to omega square in bracket a square minus 16, and this will be equal to 64 omega square a square minus 25. So let us take this equation as number 3 and this is as equation number 4. So if I subtract the equation number 4 from the equation number 3, I will be getting 100 minus 64. This is equal to, now if I open the brackets, then omega square a square minus 16 omega square minus omega square a square, and minus will become plus 25 omega square. So here this omega square a square will get cancelled out, and finally I will be left with 36 is equal to, now 25 minus 16 is equal to 9 omega square. So from here I am getting the value of omega square as 36 by 9. So this is equal to 4, or we can say the value of omega is equal to 4. This is equal to 4 radians per second. Now we have to find the time period. Now time period is equal to 2 pi upon omega. So we can write this time period as 2 pi divided by this omega, and here omega is omega here is equal to 2 radians per second, because this is omega square is equal to 4, so omega is equal to 2 radians per second, and t is equal to 2 pi upon omega, so t is equal to 2 pi upon 2. So the time period will be equal to pi seconds, or we can say that its periodic time is equal to pi seconds, or the correct option will be A. So in this question, the most important thing was the utilization of this formula, that is V is equal to omega under root a square minus y square, and then after finding the value of omega, we had used the equation, that is time period is equal to 2 pi upon omega. So by substituting the value of omega in this equation, we were able to find the periodic time of this simple harmonic motion of this body, whose velocity is 10 centimeter and 8 centimeter, when its displacement was 4 centimeter and 5 centimeter from its mean position. So thank you very much for joining this session. In the next session, I will be discussing about the spring, the effective spring constant of the series combination of springs and the parallel combination of the springs. And thereafter we will be also discussing about its time period, how to calculate the time period and the effective spring constant when the springs are connected in parallel and series. So thank you very much again for joining this session. Till then, have a nice day. Bye.